So this is, I like this picture. This is magnetic core memory. Those are little disc ceramic magnets, just like the great big ones that I have. I don't have them out, right? But I've had these little round ceramic magnets like stuck to the board and everything like that. You guys played with them. They are sewn in there. This is the original memory before it was like solid state, right? In college, our analyzer for the nuclear experimentation thing used magnetic core memory. It's great stuff. It's great stuff. You can turn off the power and it still stays magnetized, right? But it actually has to be hand sewn. A person sewed all those little wires through there so that you can read and write and access every single bit. Every single one is a bit, and you store information on it by either making it North Pole one way or North Pole the other way, right? Here's a CD, and of course you can store information on CDs, and then you can store them on DVDs, and then you can store them on Blu-ray discs too, can't you? You store a whole. How much can you store on a Blu-ray? 20 gigs. 20 gigs. Okay. Yeah. Okay. So here's the notion about binary. Okay, is that 0, 0, 0, 0, 0, 1, 1. Okay. Let's suppose we've got a number. Let's just take this number 1101. Okay. This is 4 bits, and by the way, 4 bits is called a nibble. 8 bits is a byte. A byte is made of 2 nibbles. This is kind of somebody's got a sense of humor, don't they? Yeah. But honestly, God, they are called nibbles, and I'm very sorry about that, right? A nibble can be represented by 1 hexadecimal digit. A nibble can be represented by 1 hexadecimal digit, which is what, 0 through F or something like that, right? So 0 through 9, A, B, C, D, E, F, right? Okay, and good programmers, I'm not a good programmer, but people that do a lot of stuff with binary, they can tell you exactly which bits are on and off for every nibble by its hexadecimal number. Yeah? They can say, oh, well, the 3rd bit wouldn't be on. I have to like write them all out and look them up. Okay? But anyway, what this means, 1101, okay, what this means is that it's 1 times 2 to the 3rd plus 1 times 2 to the 2nd plus 0 times 2 to the 1 plus 1 times 2 to the 0, right? And just to refresh our memory, 2 to the 0 is 1, okay? So to do this, to convert this number to decimal is very simple. Just type that expression into your calculator. Obviously, you don't need to say 1 times and 0 times, right? So take your calculator right now, right, and go 2 to the 3rd plus 2 to the 2 plus 1. And you'll get that equals 13. Yeah? Yeah? The interesting thing is that this process that we just did is something very similar to what electronics do when they do digital to analog digital to analog conversion. Okay? A DAC does something very similar, digital to analog converter, right? Now you're saying, gee, what is a DAC? When you listen to your iPod, you're listening to the output of a DAC, a digital to analog converter. The information is digital inside the iPod, and it converts it to analog because it's got to change it to a voltage so that the speakers go back and forth, yeah? And you're near your ear, like that. Okay, this can be done very, very rapidly. It's a very simple process. The opposite, though, is not quite so simple, right? So this is how you convert digital to analog, kind of, right? Okay, but what you need to know, and let's just do all 8 bits, right? Okay, 2 to the 7th is 128, isn't it? 2 to the 6th is, I think it's 64, right? 2 to the 5th is 32, right? 2 to the 4th is 16, isn't it? 2 to the 3rd is 8, right? 2 to the 2nd is 4. 2 to the 1 is 2. 2 to the 0 is 1. Yeah? Isn't it? Yeah, there we go. Okay, so if you were going to convert a great big complicated number, like, oh, I don't know, 237, okay? If you're going to convert 237 into binary, what you do is you just start at the left side. And by the way, there are things that go from analog to digital, and they do exactly the same thing. They just go too much, too little. Can you get one of these out of it? Can you subtract 128 from this? Oh, I believe you can. So minus 128, right? And that, by the way, you got to put a 1 there, right? Okay, so 237 minus 128 is 109. That's like higher math for me, right? Okay, can you subtract 64 from that? Yeah, you physically can. 64, right? So minus 64. Okay, so you put a 1 there, right? Can you subtract 32 from 45? Is what I get? Yeah, indeed you can, right? Okay, so 32. You get 13, right? Can you subtract 16 from 13? No, you can't. Can't be any of those in there, right? Okay. Okay, can you subtract 8? Yeah, minus 8. All right? Okay. Can you subtract 4 from this number, the 5? Yeah, indeed you can, right?
Yes, no, yes.
Okay, now we have 1 left. Can we subtract 2 from 1? No. Can we subtract 1 from 1?
Yes.
1, yeah, there we go. Yay. Here's our binary number. By the way, this is how we convert analog to digital, is we just have a simple circuit, and all it does is it compares. It turns this bit on, and it turns that into a voltage, and it goes, is that voltage more or less? If it's less, it keeps it on. If it's more, it turns it off. Turns on the next bit. Keeps this bit on, turns on the next bit. Is that more or less? If it's more, it turns it off. If it's less, it turns it on. Turns on the next bit. Is it more or less? Right? If it's more, it turns it off. If it's less, it turns it on. It goes boom. It has to go through. So if you're doing 16-bit conversion, right, or whatever it is, right, however many bits you're turning it into, okay, you have to go through that many times. For every single sample, you've got to have a processor that's working 16 times or 32 times or 40 times faster than the main processor, right? So think about that. If you're sampling 40,000 times a second and you've got 16-bit samples, which is what a CD, I believe, is what it is, right? Okay, then you've got something that's 40,000 times a second making 16 yes/no decisions. That's pretty damn fast, isn't it? But not all that fast, right? We can do faster than that, right? This is called, by the way, the most significant bit. This is called the least significant bit. Yeah? I don't know if you needed to know that. We're talking bits here, not bytes or nibbles or anything like that. And then, of course, a long time ago, the first computers used 8-bit bytes. That was the unit of stuff. Then pretty soon 16 bits, right? And then we have 32, and then we're headed toward 64 bits. And basically the idea now is that we just makes the pipeline bigger. The processor can grab more stuff for every cycle that it does, right? Try that one. Turn that one into decimal. I want to show you the binary solo. So crank through these, babe.